Hello, everybody, and welcome back. Root Beer here. We're going to be finishing off our Grade 8 Gauss paper from 2012. That's right. We're at the last question at number 25. So if you haven't given it a try, I would suggest you pause the video and try this one out for yourself. It appears to be just a nice little geometry question, but we'll find out together here. Okay. In the rectangle WXYZ, the parallelogram PQRS is formed as shown. We've got a whole bunch of side lengths here, so I can see that my rectangle is 9 by 15, for example. Okay. As the segment PT is perpendicular to RS, they've got that shown for us as well. The length of ST is... Okay. What can we do? If I'm looking at the sides, I'm seeing 3 and 4. I'm seeing 5 and 12. These numbers, in my mind, are conjuring up a very familiar concept. Pythagorean triples. Okay, right-angled triangles. So there's the 3, 4, 5 triangle, the 5, 12, 13 right-angled triangle. These ones are probably going to be very useful for me. Okay, so let's draw a copy of this setup here. See if we can work our way through the problem. There's my parallelogram. P, we've got to T here. This was S. I assume this is Q and R. And it was W, X, Y, and Z, wasn't it? I have P and S mistaken. E and S. Q and R will switch around. W, X, Y, Z. Okay. So we have a 5 here. So a 4 here, because I said it was a side length of 9. 12 here, and so a 3 here. 4, 5, 12, 3. Okay. Now the right angle they give me, I can also put it over here, and I see, oh, PST is right angled at T. What's more, PT is a height for my parallelogram, so I might start thinking, when do you use heights and parallelograms? Area. So areas might come into this. I know the area of the whole rectangle, and because all these smaller triangles here, the 3 4s and the 5 12s, these little triangles are right angled, I could figure out their areas. That might be helpful. Now, let's not lose sight of what we want. We want ST. I'm going to call that X. Okay? So let's learn more about the parallelogram. Well, we've got a right angled triangle up here with TWS, and so the sum of the squares of the legs must be the same as the square of the hypotenuse. So you use the Pythagorean theorem, and we see, oh, okay, you'll get a 5 here. You'll also get a 5 down here, same triangle. We can use the Pythagorean theorem again, 5 squared and 12 squared. And if you need to, you grab your calculator to work these out. I've seen these, countless times. So I know that PQ, the hypotenuse of PXQ, that right angle triangle, must be 13. Okay. So now, if I just look at my parallelogram, we'll sort of tilt it off to the side here. We're being asked for this X here. I've got the PT, and the reason it sticks out to me is it looks like the height of a parallelogram, and I also know the base of my parallelogram is 13, and these sides over here are 5, but I don't think I'm really going to need those 5s right now. Okay? But I will need that 5, because if I can figure out the height of this parallelogram, 5 must be h squared plus x squared, and that's how we can get x. It's a very good idea for questions, especially the later questions on the paper, to try and think of a plan of attack. So I used the Pythagorean theorem. I figured out these sides, 13's 5s. Now I sort of want to see where should I go with this? What should I be looking for next, aside from the obvious? Okay? So here's what I can definitely say. X squared is 5 squared, or 25, minus x squared, or minus h squared. So to find x, maybe I just need to find h. Okay? H is a height. So 13 times h, base times height, is how you work out area of a parallelogram. Okay? So now to find x, all I need is the area of a parallelogram. Okay? But, well, how do I find the area of this parallelogram? Okay? And that might be a sticking point for you for a moment. Until, as I said, you might realize, oh, the whole rectangle is a 9 by 15. So the area of the rectangle, 9 times 15, is 135. And then to make my parallelogram, we take away these two triangles here. So we take away two triangles who have area of 1/2 base times height. And then two more triangles get taken away that have base and height of 5 and 12. So formula for the area of those triangles, 1/2 base times height. Okay. So what's left over is my parallelogram. So we take the whole area. The 2's and the halves can cancel out. So minus 12, and 5 times 12 is 60. So 135 minus 72, 63 is the area of my parallelogram. Okay? But then what did we say? Area of the parallelogram is 63, but that's 13h. So now I know the height is 63 over 13, and sadly this isn't a nice, neat integer. Okay? 63 has no factors of 13, but now I can work out what x squared is. X squared is 5 squared minus h squared. And here's where we might grab a calculator and work some things out. So 25 minus 13 squared is 169. Remember, to square fractions, you square the top and square the bottom. 63 squared is not one that I have memorized. Looks like it's 3,969. So here I am actually using my calculator. Although I suppose we could work it out by hand if we really wanted to. So if you didn't have your calculator, you could still work this out. You know, just do 63 times 63. Do it like you learned a long time ago. Okay. Now, how can I subtract this from 25? Well, we need ourselves a common denominator. So 25 times 169, 4,225. Okay. And we subtract away the, now that we've got a common denominator, we get 256 over 169. So that's x squared. So to find x, we just take the square root. Square root of the bottom is 13. And the square root of 256 is 16. And so the length, I think it was st, must be 16 thirteenths. And that's an answer of D. Okay? And that'll finish the paper off quite nicely. Okay? Now, there might have been a faster way to see this, just something I just thought of right now. If I had left it as 5 squared minus 63 over 13 squared, we might have said, well, I'm going to have to get fractions eventually, and said, oh, 65 over 13 is 5. And you might have recognized, and this is if you really, really know your Pythagorean triple, like this took me a moment to think this one through, so it didn't jump in my head. But 63 and 65 are part of a Pythagorean triple. Okay? A 16, 63, 65 triangle. And if you knew this one, you wouldn't actually have to do the calculations. Okay? You would have said, 65 squared minus 63 squared all over 13 squared, and that's just 16 squared, or 13 squared. And that would have gotten you the value of x squared ever so slightly faster. As I say, I mean, this isn't even one that I have read, jumping right into my head when I think Pythagorean triples, but certainly does help. Okay, so we used the right angle triangle, Pythagorean triples, or Pythagorean triangles with those 3 4s and those 5 12s to get us some of the sides of our parallelogram, And then we had to think and use area. And we used the areas of those triangles from the area of the rectangle. That got us the area of the parallelogram, which got us the height of our parallelogram. And then we had another Pythagorean Pythagorean triangle, another right angle triangle at the end there. Okay? And when all is said and done, we got ourselves an answer of D. Okay? So that's it for our grade 8 Gauss, at least from the 2012 year. If you're looking for more grade 8 Gausses, I've got plenty more that you're welcome to try all over the channel, so feel free to browse them. If you're looking for something harder, might I recommend the grade 9 Pascal paper? Okay? But it's entirely up to you. Thank you so much for watching, and I'll see you for more math in the future.